Hello everyone. Welcome back to class. It's me, your teacher, and today we will be learning about scientific notation. Now, to begin, who can tell me how big they think the moon is in kilograms specifically? Here's our moon. Those are all really good guesses, but specifically, the moon is 7. $70 sextillion is the size of our moon, which is a very, very big number. We don't really want to work with that. It's a huge number, and you can make many mistakes with it. So, what good old Archimedes did, which was a Greek inventor, here he is, yay, made a great idea and created scientific notation, which takes big numbers, or very small numbers, and makes it to where we can deal with them easier. So, to begin to understand this, we first have to understand something like 10 squared. Who can tell me what that means? Yeah. 10 squared means 10 multiplied by itself twice. So 10 times 10, which would equal 100. Similar with 10 to the third power, which would be 10 multiplied by itself 3 times, which would be 1,000. One more time, 10 to the 4th power, which would be, correct, 10 times 10 times 10 times 10. 10,000. As you can probably notice, the number of zeros in this number equals the superscript. See? 3 zeros, 3 is the superscript. 4 zeros, 4 is the superscript. So, if I were to tell you that 70 sextillion has 22 zeros in it, how do you think it would look in terms of this? Yeah, you're right. 10 to the 22nd power. But this number is this 7 times over. That would mean it'd be 7 times 10 to the 22nd power in kilograms, of course. Another way to think of this is to ask yourself, where in this number does the decimal lie? Yes, at the very end. And if we want this big number and this decimal to reach 7, we would have to move the decimal over. How many times do you think? 22 times. So let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Look at that. 7 times 10 to the 22nd power, because we move this decimal 22 times that way. Now, it's not always going to be like this, because we are also going to be working with very small numbers. So, to understand that, we have to know that when the decimal moves this way, this number right here is going to be positive. And when it moves this way, the number is going to be negative. And I'll show you that right now. You'll get this down. So, how do y'all think a proton is? Boop. That little guy, which is literally everywhere. How big in kilograms do you think this weighs? Those are all very good guesses, but the real answer is this is a very small number. And we don't want to work with it when we can do something so much simpler, thanks to this guy. So, how big is this? We need to move this decimal all the way so that it equals 1.675. Here, let's put 1.675. That's the number that we're looking for. Times 10. What is the superscript here? Let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 27. But remember, if we're moving the decimal this way, the superscript will be negative. Therefore, the size of a proton is, everyone let's say it, 1.675 times 10 to the negative 27th power in kilograms. Alright. Do you have any questions so far? So, I'm going to erase this if that's fine with everyone. I'm going to be handing out a worksheet so that we can all look at the same problems. So, let's look at number 7. Number 7 says, $200,000. Now, how will we write this in scientific notation? We want our number to be 2, right? Therefore, we want the decimal to be right here. And if it starts out right here, we're going to start with 1, 2, 3, 4, 5. That means we would write it as 2 times 10 to what power? The 5th. And since we're moving this way, it's going to be positive. I'm going to use a different mark. Is that making sense to you? Let's look at number 10. 0.00009. If we want this decimal point to be right here, we're going to go 1, 2, 3, 4, 5, 6 places over. What should mean? Now this number is 9. 9 times 10 to the 1, 2, 3, 4, 5, 6 power. But since we're going this way, what does that mean? It'll be negative. So, 9 times 10 to the negative 6th power. Right? Y'all got any questions so far? Questions? Complaints? Don't tell me complaints. Okay. So, what if I were to ask you this? Look at number 8. 71 times 10 to the 3rd power. Probably telling me, Mr. Lightboy, That number's already in scientific notation. I don't know what you want from it. But sometimes we want to look at the actual number. And in order to do that, what do you think we have to do? Let's break it down. 71, the decimal place is right here. And this is asking me to move how many places over? 3, yeah. And since it's positive 3, we're going to be moving this way. So, 1, 2, 3. And in this place, we add a 0, which would mean 0.071 is the actual number. That making sense to everyone? Okay. I'm going to put a question up on the board, and I'm going to call out on someone, and y'all can come up here and do it yourself. I want to see you work. Let's do number 2. $54 million. Who wants to do it? Who's next?